Okay, cool. Good morning, good evening, and good afternoon for the folks whoever is joining from different time zones. Thanks for joining for this webinar, right? So, does AI ML compete with security of professionals or complement them, right? Such an interesting topic, which will be discussed by Archan Chowdhury and Abhishek Agarwal, right? So, I'm not sure, how many of you know Cetas Cyber, right? We are basically lifelong cybersecurity professionals on a mission to improve life of incident responders and security analysts, right? And how do we do it? We use, domain expertise, automation, and artificial intelligence, right? Those are the backbones of for this particular product, right? And we are basically headquartered in Palo Alto, US, and we also have offices in Bangalore and Gurgaon, right? That's quick intro about the company, right? So, you guys know, right? So the attackers are already using AI to come up with cybersecurity attacks, right? So when they are using, right, why not, cybersecurity professionals can, use AI to defend against those attacks, right? That's the agenda for today, right? Where we'll talk about history, how things were for last 5 years, right? How AI ML evolved in cybersecurity space, right? And how it will basically affect cybersecurity professionals, right? And of course, the interesting real life use cases and and also the application of an AI ML in cybersecurity, a demo from Abhishek, right? So we'll be doing this would be the agenda for today, right? Speakers, as you already know, right, one of the top cybersecurity professionals, from India, Archan Chowdhury, right, who would be walking us through all this, the objectives that we discussed, right? And he has, close to a decade experience in cybersecurity, right? I'll let him introduce himself in a minute, right? So we also have Abhishek, who is product head at Cetas Cyber, right? Who is an innovator in cybersecurity industry himself, right? So bit of housekeeping. So most of the attendees will be on mute, but chat section is open. So if you have any questions at any point of time, please drop in your questions. We will answer those questions in the end. And also there would be a couple of polls in between. Please try to answer those polls as well, right? So on that note, I'll hand it over to Achan. Achan, floor is yours.
Thank you. Thank you, Adarsh. Why we are here today? I know there are multiple things going on, might be in your mind that in terms of like AI ML, whether it's only a buzzword or whether actually we are operationalizing any AI ML stuff into security operations. So why we are enhancing our survival techniques, right? As others mentioned. So attackers are evolving. They use cutting edge technologies and they talk very much less than the portion of talk that we do. They talk too much within themselves, and they are really uh, they are in the first game, rather what we are actually lagging behind. So whether we are in the same portions and we have to be in a position that we can match with them, so we have to enhance our survival techniques, and I will show you in a second like what actually do I mean by that. Now without even maturing our intelligence portion, like the manual stuff, keep on acknowledging the regular kind of tickets, how actually security operation thing works, we cannot survive on a longer term, right? Because we are working on a huge number of data set that we call as daemon, and you cannot even imagine that what amount of volume of data that we have to analyze, right? Being an incident responder for like an ages, and while especially in some portions, like if you talk about threat hunt and other scenarios, if you can imagine, so I won't even talk about cloud, but if we only talk about on-premise, we actually process terabytes of data per day, 7 to 10 terabytes of data per day that I have seen in my personal life. Now, if you are creating anything, any detection topology, anything without having any intelligence at your hand, right? You cannot do that. A tool cannot support it, or even human eye cannot support it. So that portions come into our mind. So are we really evolving? So now when we go to that, that brings to our next thing, our evaluation of our security metrics. Okay, so I call it as security metrics mesh. Why I call it as? Because if we see the spider chart, it's a quite popular spider chart by NIST framework. Now there are different kind of areas, right, that we actually cover in security operations. So it could be starting from the asset management, governance, risk assessment, supply chain management, and all of the things that you can currently see in the screen. Now, each and every sector of a particular operations has huge number of volumes of data that keeps on generating on your backend, right? Now we can talk about SIM, we can talk about different correlation engine, but in reality, if you talk about everything, right? So now how the data is actually evolving and how our risk factor is actually evolving, we cannot match with it without having any proper intelligence source or a real life solution at our hand that can actually help us to churn out all those events that we can keep on digging manual basis, right? So in terms of like from 0 to 5, if we match our own organization, like the organization we work on, probably we will be in some position like 3 to 2. And I'm not talking on behalf of my organization, but I'm talking in a general aspect on all of my clients and all of the other vendors that I have worked on. Now, in terms of that, if that evaluating security aspect, right? So we need to keep one thing, very important thing in mind, that the data source, the volume, and the cost, right? Both things are very important, right? If you can ingest like terabytes of data into your SIM, there are actually tactical problem that can handle. So I'll come up in a second. So let me move on now. How the incident response maturity model actually works, right? So in the left-hand section, you will see the kind of linear diagram that we mark from 1 to 5. Okay, so most of the organization, right, in today's aspect, if it is like a smaller to mid-level organization, they ponder around the level 3, right? So where they are actually process driven, they actually do some kind of internal hunting. It could be something like IOC search based on the threat intelligence that they gather on their SIM platform. Some are bound of their SLA driven, and so we call it as medium. Now, if we are maturing and if we want to keep up with the threat actors, the way actually they are evolving, we have to be in a position either like 5 or 6. 6 is not even there in the sheet, right? But we have to aim for it. Now, if we have to aim for it, so obviously keeping mind incident response lifecycle, everything cannot be done manually. So the work that you are doing redundantly. So we will see that when we will see a demo that how different kind of aspect scenario can be fully automated. Okay, and the creation of the security matrices, then creation of the detection engine, and not only that, but also resolution of that particular model, resolution of a particular incident from triaging to the end. All of the steps needs to be automated. Otherwise, we will be in a situation that, hey, there are like thousands of alerts coming, and day by day it could be increasing because the number of log sources, number of volumes, number of a scope actually basically that you will be getting into your friction, it will day by day it will be increasing, right? It is not going to decrease. And now if we have to map everything with the attacker perspective, like let's imagine a simple situation. Okay, so if we talk about today attack meter framework, right? So they have around like 14 to 15 tactics. Each of them are mapped with 10 to 15 techniques. Okay, and if we talk about the tool, we don't know how many tools there are available in the market, right? Now you can create simple like 2-3 workspaces, okay, 2-3 rules based on one TTP MITRE framework. But what if I say that they are to actually have a particular log source, have it fully covered for a particular threat actor, you need at least 2000 to 3000 models, right? Model, I mean use case, you can call it rules or whatever maybe you can call it, but without even doing that, you cannot process your data. You cannot tell your boss or your CISO that, hey, I am fully covered, right? So that is the angle we are actually approaching, and how we can approach that I will show you in a second. So now moving on, security operation evaluation, right? So the chart is quite older. Now, if we talk about something when we started our operations, maybe back in 1990s, there were only network alerts we actually see, right? So there are some people like who are actually NOC people. So NOC really exists today also, but in a different aspect, okay? So we only see the packets on the firewall, not even the full packets also, right? So based on the routing tables, how actually which packets we should allow or which packet we should drop. So we have seen those kind of alerts in network level in way back 1990. So now when internal SOC like security operations center kind of model got into the picture in around like 2000, so we have different kind of antivirus solution, IDS solution, firewalls, and all those stuffs keep on coming in, right? Now, in my life, whatever companies I have worked on, whatever tools I have worked on, I have seen next gen SIM tool next to next gen SIM tool, and also I have seen SOC version 1, 2, 3, 4, and I don't know like how basically those things can be actually categorized properly if we are not evolving from your core strategy. Now, in pen and paper, everything seems to be smoother, that you are actually going from SOC 0.1 to SOC version 3. Maybe you are getting your DLP, you are getting your advanced persistent threat mechanism, Azure IDP, lot of tools. You can imagine if you are working on a SOC environment, like you will tend to work on 10 to 15 tools at a day, and you will be getting all those alarms junked into your SIM, and your SIM will also be working on a high frequency level to work on all the models, all the correlation rules and whatnot. Now, just imagine in that situation right now, in current situation, we are not only thinking about anything a singular pattern, right? Not only network alert, not only alert from your EDR, not only alert from your VAPT tools, DLP, CAS, big data, data lake, not a single source, right? So today we are talking about everything. Now, when we have this data lake into our picture, now if we talk about cloud, if we shift VPC flow logs, just as an example from AWS, it will be terabytes of data one day. Now, how will you identify whether a particular data is behaving anomalous way, right? So I will now talk about the different things that security challenges that a SOC is facing today, right? So most of the people we know about false positives, right? So we are sitting on a huge number of data sets, huge number of volumes of log, alerts, rules, and whatnot. Now, all of them are prone to be false positive. Now, we only are the back ends of it, right? We only have to deal with the false positives. We only have to tackle with those false positives to tell our tool that, hey, this is actually a false positive. We need to tune our logic. Now, how we basically tune our logic in most of the cases, I am not too much talking about the correlation rule, because there are also some kind of limitation. Whatever tool you talk about, like Splunk, QRadar, ElasticSIM, we have a nomenclature we call as threshold-based correlation rules. Right now, it could be multi-layered rule. By the way, you can talk it like, if we talk it a simple password brute force attack or password spraying attack also, right? So you will at the back end, you will set some kind of threshold, right? But that threshold will be only one tip of the iceberg. Right now, if I am talking about terabytes of data, you actually need to identify what is the outliner of that particular terabytes of data, right? Not only which data is crossing your threshold and you can just bump up one alert, right? That would increase your rate of false positive, and that would increase your burnout rate also, right? And everything, whatever these puzzles are actually getting together, it is actually correlated. Now, false positive will also keep your SOC and content development team running, and analysts also keep on running to create and mature their content development portions. Manual investigation prioritization will also be tip top, and that is actually related with our matrices, which we call as MTTR or MTTD, mean time to resolve, mean time to detect. Now, currently in a SOC, whatever the analytics that I have seen, more than 50 to 60% alert just get closed like that way without taking any action. That because we are sitting on a like huge amount of data set, and we actually don't know what we are talking about, right? Now, in the pandemic situation, there are more things coming into picture, right? So we are in remote SOC. There are BIOD systems coming into picture. We don't know what is the scope of all of those things about. So, and we are really in a painful situation, not only just creating rules, managing our stuffs, but everything going in the flow of manual direction, right? So that needs to do some involvement in that area. So that brings to our, I believe, poll number 1. So Adarsh?
Yeah. So team, you will see the poll now. Yeah. So if you could just respond, that would be great.
And so bear in mind, so what is the question is actually, so fully automated.
Okay, 2 responses, 3 responses. Seven. Yeah, we'll just wait for a minute to end, and then we'll have a result out. Yeah.
Okay.
Well, responses, good. Okay. Cool. I think, yeah, we are leading with, rules and detection model creation, has 64 plus percentage of votes. So yeah, you want to talk about that, Achin? Incident response is one option, rules detection model creation, and the last is threat hunt. And the audience thinks that, rules could be, kind of automated.
Yeah. Yeah, that is true. So rules and detection model creation can be fully automated. But in terms of like thinking in a scenario that if you are ingesting like terabytes of data, and based on the matching kind of scenario, that which rule has to be matched with which kind of data set, and which rule has to be matched off with kind of risk factor, right? So yeah, I agree that it can be fully automated, but at what cost, right? So that we need to keep in mind. Also, while I will talk about the things that currently we are in the market of like AI, and we are talking about it, right? So there are also risk associated with it, whether you are automating the full cycle from starting to the fine tuning portion. So there are also shortcomings in that area. But yeah, I agree that can be fully automated, and I believe that while we show the demo, that will also be in the picture, like how Cetas is solving that problem, right? Okay, so I'll move on. Okay, so this is my past SOC model that I have built in one of my previous client that I have worked on. So it was built on a principle of collaboration of automation. Okay, so not only from like perspective of rule creation, but everything. So we started ingesting the log. So our full automation sector is based on our cloud development. Now, from starting of a particular incident or any kind of metric, let's say if we talk about a guard duty alarm, we used to have a Lambda function that used to keep on monitoring if there is any guard duty alarm got triggered. That Lambda function used to keep on writing different kind of step function if we know about the step function. So those are basically actually the actions. So what action we have to take based on what kind of alert guard duty has thrown to us. Okay, based on those step function, we used to take the machine out of the equation to the forensics in terms of like collecting some redundant data out of the machine from an EC2 host and collect all of the evidence according to that particular AWS resource. Okay, and keep it with our incident responder VPC that has to be spinned up in an instance when a incident occurs. And after that, we go back to the actual resource and clean it up in terms of creating a new instance at the place. So full collaboration has been automated and we use heavily. There are many tools like in terms of SOAR, we deployed and we use many kind of those tools. But one thing was very shortcoming in terms of the situation that the portions of automation what we did that was some kind of tool specific. Okay, and those are built in-house. Those are not so much of scalable in terms of like what activity we are doing. Not every SOAR can handle each and every kind of aspect. Okay, so I have worked on Phantom, if you have heard about, then Times also, then other free versions of SOAR as well. Okay, so now all of them has some beautiful features inbuilt on them, but none of the tool actually solve the full process of doing the full kind of automation when we talk about an incident response, right? So starting from an alert, then ending to that particular alert phase in security operations. And also not only that, if we talk about the other factors also, right? So if we talk about other things like threat hunt, intelligence gathering, then in terms of like forensics acquisition and all those stuffs can be somehow automated with the SOAR playbook, but not everything, because at the back end, if we want to customize a particular model in your SOAR playbook, you have to write the codes, right? Without code, you cannot do that. It could be Python, it could be Golang, it could be Rust, anything, but you have to write the code if you want to build a custom playbook out of it. So there are dependency, right? And also in my past SOC model, why I want to bring that into the picture, because we were only 6 people of team, right? There are no huge like L1, L2, L3 people over there. So we all are L4 or L5 people. We all are doing the same activity, starting from the monitoring till the forensic. So that is the some kind of structure the industry is also going towards. Okay, so I'm not saying that that will kill the actual work of L0 or L1 level of analyst, but those days are actually gone when we hire a bunch of L1 people to do the monitoring in front of screen, right? Because we have tools to do that. We have built automation for that. Now we are enabling our those L1, L2 people to become L3 people so that they can handle different kind of aspect of investigation. Okay, so different kind of forensic analysis, different kind of malware investigation, reversing a code, debugging a code and whatnot. Okay, so that we have to enable and keep in mind when we talk about different kind of SOC model. So yeah, we were actually used to call people used to call us a zoo of intelligence, because yeah, we were actually some intelligent people sitting over there. We have built an automation and all those stuff, but there are also shortcomings. Okay, so while I show the picture, what is the actual problem in all those kind of SOC, whatever automation you have built. Okay, so now if we talk about this pane of pyramid, it's kind of similar kind of structure. We have hired from the threat hunt pane of pyramid. Now revenue loss is very big factor, brand value and data security. Those are the 3 major factors on top of which we are currently leveraging, right? If we simply take an example of the Uber Breeze, right? So there are multiple scenarios going into the picture. So revenue loss is obviously one thing, brand value, majority of the brand value, right? So now you will see that people are actually screaming at Uber, right? But no one actually seeing the actual problem. Where is the actual problem? Now, being in the SOC, being in the security operations, we are actually setting up millions of malicious website, and human eye is like just you cannot teach each and every human that this is a malicious one and this is a non-malicious one, right? So human is we also are like we are prone to do mistakes, and we are actually greedy, right? So if you just give them one lucrative phishing email, they tend to capture that. So that was also the initial factor of Uber, right? So doing the social engineering stuff and then get access to one of their external vendor and then going into the network. Now, how you can build your detection capabilities out of it, right? If we do not have a proper planning at hand, I'm saying too much about automation, right? But how? We know the problem, right? But how to solve it, right? So we will go gradually over there. Now, why I am telling that how is difficult. Okay, so now for a normal people, for a normal organization, from a small cap to a like large cap organization, why is the solution difficult? I told you about different kind of attack tactics and techniques, right? So ransomware, supply chain, 0 days, vulnerabilities, humans, all those have 14 to 15 tactics, which are all covering 10 to 15 each techniques, which making is like 300 plus, and each would have different kind of techniques as well within those tactics, right? So now, if we think about a particular scenario, modern infrastructure security, now if you merge all these three sections all together, you will be seeing like what is the demon is actually called about, right? So I am just trying to show you the bigger picture in terms of what actually you are sitting on. Believe me, guys, you are sitting on a real time bomb, right? And you don't even know that what might be happening right now at your infrastructure if you do not have the full coverage. And now your rule cannot detect all of the thing because the rules are getting created by us only, right? Either that could be out of the box rule, or we are going into our log sources. We are trying to hunt manually based on hypothesis and whatnot, and we are trying to create those loops in terms of rules, and those are getting detected in our SIEM, right? So now those are prone to mistakes. Now, why I say that those are the things are mostly important and mostly prone to mistakes, because our analysts are spending times into it, right? So I told you, right? So there is no L1, L2, L3. So everyone is doing the similar kind of job nowadays in your SOC or security engineers. And if you are an aspirant security engineer of a particular company in nowadays, that has to be in a position that you can do everything, right? You cannot do only monitoring and get a job right now in a popular or well-known security company. So now where our actually analysts are spending most of the time, right? If we talk about the time matrices of a particular alarm being triggered, when the initial event is getting triggered and time to remediate, that is our full scope of area, right? Where we actually sit on time. Now, we do not know dwell time, trust me. I have handled like thousands of incidents so far, and it is very, very difficult to understand from where or from which time zone or which uh, time unit the attacker has probed into your network, because you do not have the visibility into your network full. Okay, so I can keep on talking about different kind of incident that I have handled, but the mean time to compromise and mean time to detect, both these two factors are very much important. Okay, so mean time to compromise is a factor that attackers are going behind, and they are actually like 10 steps ahead of us, right? Where we actually do that mean time of detect. So let me tell you a quick example. So in one of my previous client, we were doing one pen testing, and while we were doing a pen testing, we had created one fake page, which actually looks like their actual page. We call it as cyber scrolling. From that page, we gained access because we tricked our one of our customer to MFA threshold attack that Uber has also the same kind of vector. we have actually gained access to the one of the environment. From there, we went ahead into, sorry, I think I moved on. Yeah, so we went ahead till their CJ infrastructure. That means their crown jewel infrastructure, and there were not a single alarm in the SOC. Okay, so we deliberately wanted to create some kind of noise. So we dropped Mimi dogs, not Mimi cats, but we dropped a Mimi dogs on one of their server. That time it created noise. They started acting, they started looking behind what is the actual trail, and somehow they identified the zero patients, what actually we have implanted on their network. So now think about that situation into your network also. So if you are sitting in front of your screen, you will see that, okay, I am totally fine. There is no alarm, or even all of the alarms, those are coming, not too much concerning. Okay, if we, and I'm not simply talking about the security that we are currently monitoring. There are very niche security also that we have to ponder on, like IoT devices. There are embedded devices we call upon. If we talk about cameras, right, security cameras. Now there are also scenarios that security cameras also can be probed, and the PII information of a customer can be exported out of those monitoring cameras. So I have seen situation also like that. But if you are sitting in front of your screen and if you are seeing that, hey, everything is fine, that's not gonna work, right? So that is the main area. Now if I go to the SOC visibility model quickly, so this blue diagram we all must be knowing, and Gartner has this triangle shape diagram, right? So we are sitting in some kind of triangle, and we tell that SIEM has everything, right? We trust our SIEM because I know security operations cannot really run without having a correlation engine. And we all know, what do I mean by correlation engine? It has to be a SIEM, right? Or it has to be some kind of intelligent tool, the namesake intelligent tool, which can do the job on behalf of us, right? It could be doing the analytics and reporting. It has a database. It will do the indexing. It will do the normalization and collection, all of those stuffs. Okay, and it should be capable of handling all kind of data structure, right? It could be routers, switches, endpoints, Linux machines, then IoT devices, server, and whatnot. Now that is an ideal situation. We call it that is a SIEM, right? So we are in a triangle position where we are currently merging SIEM with user behavior analytics and network detection and response model with the endpoint detection and response models. We are trying to do some kind of collaboration between network detection model and endpoint detection model in terms of elaborating that education model with the user behavior. So that we call as user behavior analytics, right? UEBA. Now that has a shortcoming also. Okay, so now if I go to the hunting strategy and hunting scenario model, now just look at this particular model, guys. So this is a very generalistic view. Okay, left hand side has been taken from a Jupyter notebook, and the right hand side has been taken from a Google Doc website. Okay, so now these are also particular tool. Most of the people might be familiar with Jupyter notebook. Now see this particular pattern. Okay, so the blue line tells us that we are all safe, and these are all the normalized log. Now those red bullets or red bubbles are outliners. Okay, and also if you see the similar kind of portion in the right hand section in the John MVP asset, you will see that there are also bubbles standing up from each and every location. Okay, now see the difference between two of them. I am talking about AI/ML, right? I am talking about machine learning. Now, this left-hand side graph has been prepared with some machine learning algorithm where we call the outliner detection, where we ship database like ship database log, engine logs, and terabytes of log. We apply some ML models on them. We apply some behavioral pattern algorithm on them, and we try to identify which particular event is trying to behave abnormally and trying to behave beyond my scope of agenda, right? So that we call as the outliner detection. Now, if we are only creating those models, again, I am telling you, right? We are trying to do the automation, but there has to be some manual inflow in terms of creating those algorithms, writing those algorithms, coding those algorithms, right? Codifying those algorithms, okay? Now, if we are in that particular phase, if we do some mistakes, obviously there will be a lot of bubbles coming up, right? And you will see that there are a lot of outliners, what you actually didn't anticipate it. Now, with this particular diagram, this is a very generalistic view. You cannot take a particular action on a SOC, okay? Because you know, might be a VPC flow log is behaving abnormally. Maybe it generated from a device which you haven't seen so far. It is an outliner for you, but you cannot really take a quick action out of it, right? If I talk about the right-hand side map, this is one asset detection, right? Now, if you see there are events coming up from this particular machine, but to take a particular action, you have to get a very specialized view, right? So now I have taken this particular image from CrowdStrike. Now, what do I mean that particular specialized view? Okay, so now if there is a process injection that happens at your endpoint, now your EDR solution is capable of doing multiple phases in terms of showing the actual process tree, what is the command line argument it is behaving, how if we talk about something like a log4j kind of incident, right? Now, if a process being probed at your endpoint, your EDR will give you all those details in terms of which actual process might have got infected. So you see there is a crypto miner, okay, but it was executed from an Explorer command, then PowerShell, and then it has launched a multiple fragile of chains, and there was a crypto miner.exe was launched. Now, in this specialized view, you can take really some action, right? Now just think the situation where I shown you the previous slide. Okay, so if I go back for a minute in the previous slide, now you can build similar ML model detection manually. Okay, and you can create your detection topology in terms of your generalistic view to get those kind of details. Now you imagine this generalistic view has so much of data. Okay, now if you try to do the specialization of view, how big your data source would be? Your data source would be like a huge, like it would be petabytes of data, right? And your machine, your algorithms cannot handle those data, right? So that is the maturity model we are actually shipping today, and that is the whole purpose of our this workshop. And that will be clear in a second. Well, we will show the demo and how we are trying to solve that particular problem. So that brings us to our second poll. So Adarsh.
Yep, you will see the poll now. What's the biggest challenge in security operations while we automate? Right, so you try to automate all of these tasks, and what could be the probable challenges, right? So you have three options: false positives, lack of skill sets, and legacy assets, right? So please submit your responses. 9 responses. I think false positive is leading. Yeah, I think everyone is kind of towards false positive. Yeah. Cool.
Yeah.
What do you want to comment on that, Chan? Yeah.
Yes, I knew that gonna come up. Now, while we show actually the demo, we will actually see that how the false positive reduction can also be automated, so that that loop will goes on, and we will create some friction out of it, and we will say that, hey, we have introduced this much of data, and our rule creation has been automated, our detection topology has been automated, and false positive reduction is being done by the tool itself, not by humans. Okay, so that full chain will be automated, so that that biggest risk in the automation today is false positive, that can be reduced. But one thing bear in mind, false positive will be in higher volume if your model creation algorithm is not proficient enough, okay, and it is not handling your data proficient enough. Okay, we will see that in a second. So I think I am almost done, so I'll now over to you, Abhishek. So please take on. I'll then stop sharing my screen.
Yeah, thanks, Arjun. Thanks for all your insights. So idea is to divide the time within the presentation, giving you the conceptually how and what we do, and then we'll just take on to the demo and quickly show you how practically we are doing, right? So I'll talk about the two poles, right? So majorly we talked about automating the model creation piece and how we can reduce the false positive, overall the reduction of false positive or noisy alerts, right? So I want to cover the autonomous model creation introduced by Cetas, how it is effective, how we can detect proactively, how we can remediate proactively, right? So I'll just, without wasting time, again, please, any questions, you either stop me or please post a question, right? I'll quickly respond to that. I'll talk about, again, Arjun gave us insight like the modern data stack we have, right? We talked about the volume, the terabyte and petabytes of data we have to process every day, right? Nearly 10 petabytes of data is again, a normal organization is producing every day when introducing the cloud, introducing the SaaS. So when we talk about the stack, we know that we have identity and HR applications. We have EDR, CrowdStrike, Sophos. We have SaaS applications. We have cloud, right? Google, Amazon. Again, going back to network logs, going back to vulnerability data, the databases, right? MySQL, SQL Server, directories, Beyond Trust, DLP, big data, immutable infra, IoT devices, and more, right? So all these variety of data we have to literally process every day. We have to have the analytical coverage. Anything gone wrong, we have to really catch through the tools or models we are trying to create, right? So this is again just a summarization of typically as part of the standard connectors or endpoints we see. We have at this point in 2022 more than 250 different applications or different data sets we really have to deal with when it comes to security, right? Now, talking about the data, modern data stack, but I want to just quickly spend time on the complexity of this data stack right now. Now, I'll just take a couple of examples how complex the data can be and how it is really, which looks easy to create models, how it can be really difficult, right? So I'll just quickly talk about one of the identity and HR, which is Okta. Again, we all know Okta is authentication log, someone logging from remote location Okta, there is a log captured within the Okta, right? Storage. Now, what we have is, again, just to give you quick glimpse of like how many attributes or data points we really have to deal with when it comes to Okta. We have more than 80 attributes, someone logging from what city, what location, what was the latitude, longitude, what was the authentication step, what was the provider name, what was the agent, right? All these different attributes or data points we just have to consider when we are considering only Okta. Likewise, if I want to talk about one of the EDR solution, you can take again CrowdStrike or Sophos. These are the typical attributes we really have to process, or in order to detect something bad is happening, we have to have rules or model coverage around all these different attributes, be it file hash, file path, or again, it can be the user event description, right? I'll just take one more example. We can take normal cloud AWS infra, where we can take cloud trail logs, again, 40 plus different attributes when it comes to just the cloud trail logs, right? So this is the complexity when it comes to the variety of data we have to deal with when in order to create the rules and models, in order to have the analytical coverage, right? Now, I'm going to talk about the traditional way how a typical SOC deals with this problem of having the rules and models, right? So this is just one glimpse of what traditional SOC does in order to have the coverage, analytical coverage, be it rules or models, right? So again, just considering n data sets into say we have 40 attributes for every data sets. What we are trying to do here is we are relying on human here. So traditional SOC relies on human, as Archana said, something happens, a human goes into the domain expertise, research analysis, some kind of coding or query skills, and hours of efforts, there will be some coverage. But the question is, again, with the limited coverage and the models, is it really enough? That's where question comes with the reactive approach, where building these models by human, having a reactionary approach, is it sufficient to have the adequate analytical coverage, right? That's where, keeping that in mind, we have introduced the Cetas module, which we are calling it as AMC, Autonomous Model Creation. I want to just quickly give you a glimpse what AMC does here. It's completely powered by AI. What we have is all the data we are really trying to process. We have autonomous model building by AI in real time. We are absolutely not relying on human to build the models. We do have models or rules customized by human as well, but as a primary coverage, we are giving you models without absolutely any human intervention. Right now, what these models are being offered by Cetas, these are again across all data sets, across all the attributes I talked about, across all the different data science parameters in terms of complexity. I'm going to spend some time here. And then the most important, which even Arjun spent some time, the MITRE tactics and techniques. So just to give you how Cetas is trying to operate SOC, right, compared to the traditional SOC, all we have to do is again implementing or operationalizing the Cetas AMC, where we can in return getting thousands of models, absolutely 100% coverage, minimalistic human effort or no human effort. And again, we don't expect you to build the code or have to have that domain expertise where human writing the models, right? So this is where attacks like, again, Arjun mentioned Uber attack, or it's a Log4j or ransomware. We are not depending on the reactionary approach. We are trying to solve the problem through proactiveness, building the models in real time, building autonomous models. Right. I want to spend some time, just give you one scenario, how this autonomous model creation can really proactively detect and remediate these recent attacks. So I'll talk about Log4j. Everybody already knows, right? I'll just spend 2 minutes how the Log4j happened and how we really not just detected, remediated Log4j. So there was an attacker, again, sitting in Russia or Ukraine. What really happened during December, January, they basically targeted vulnerable web application servers where they were inserting the JNDI lookup in the header request, right? Right after that, the log gets captured through Log4j and then directly hitting the malicious LDAP server. And then finally, request from LDAP server to the vulnerable web server with the malicious Java class. And then finally, attacker got hold of remote code execution where they could literally operate the vulnerable server. So this is just to, again, very recent attack what happened in December, January. Now, how we detected and proactively remediated in our customer and our active implementation, right? Well, just again, this is how we are doing it. Let's talk about the step one. When the attacker is trying to access the application server, what we saw, that attacker inserted in the user agent, he inserted the string, which is actually the evil LDAP server, right? That's what happened when in the payload itself, in the user agent attribute, they inserted the JNDI URL, right? Now, how we detect it, like I said, autonomous model creation creates model across all data sets, across all attributes. So this is coming from web application logs. What really happened, the information was being captured in user agent. So our Cetas engine in real time detected, like typically we see Mozilla, Chrome, Firefox, Safari as being captured in user agent. However, all of a sudden we saw something which is completely unique, which has not been seen before, and which literally is the URL to malicious LDAP server, right? So something happening on Jan 3rd, it immediately detected, and then that got alerted, right? I want to talk about, this is again majorly about the detection, but how we remediated this one. I want to talk about step 3, when the Log4j vulnerable server finally sending a request to malicious LDAP server, right? So this is where the attacker is trying to reach out to the malicious server, which is again based, which was in this case, which was based in Korea, right? Now, what is again happening here is our, like I said, right, in AWS CloudFront logs, again with AMC, there are models across multiple data science parameters across all the attributes. So what we really detected, the destination port 1389, which is again LDAP server to malicious server, that is something which is not happening in recent time. All of a sudden we were seeing the request, right? So this is where, again, the detection and remediation working hand in hand. And as Archon talked about, right, having a rule models is one thing, but correlating the rules, that is very important. That's a very complex challenge in cybersecurity. from something happening in web application logs directly to CloudFront logs, how we can correlate and give you combined risk. So I'll just quickly jump on to the application itself without wasting any time, right? So this is, just let me know if you guys can see my browser.
Yes, we can, Abhishek.
Yeah. So again, this is our demo instance. I'll just not spend time on PPT. I'll directly show you what we have. We have data coming from 48 different data sources. Like I said, there are overall 250 different applications endpoints in recent times, where you can, again, with our data integration, we can collect data from any data set through API, through syslog, through SIMs, through different integration techniques, right? So this particular demo instance has data coming from all these different applications or endpoints, right? Now, what AMC does without relying on human, what it does in real time, it builds autonomous models. So now close to 5,000 models got created instantly by machine without relying on human. Like I said, we are not absolutely relying on machine. We do have a way where human can always create models with no code platform. But now 5,000 models offered by machine within minutes of ingesting the data. Like I said, all attributes across multiple target entities, across various data science techniques, and then the most importantly, having the MITRE coverage, right? So that's where I was showing you in the PPT also. So all these different data sets, I can check for CrowdStrike data, what is my coverage, which again, the coverage I'm talking about is nearly impossible to have it through humans, right? Now, 22 attributes are there. We have models across all different attributes. We are not really relying on human to build the models and address all the attributes, right? 160 models just got created for CrowdStrike. Like I said, we have combination of sim rule as well as machine learning models, right? So this is where, again, you can see the overall coverage for every application you have ingested in, and we are not relying on human for this utility, right? So all 60 attributes are being addressed for Zscaler proxy log. 500 models got created like within minutes, right, by AMC. Now, this is where the AMC has been very impactful in terms of the coverage. But now question comes in the later part of the poll, we mentioned that the false positive is another challenge, right? I'll just spend quickly like how we are addressing the false positive challenge, right? And trying to automate even that piece where we are virtually offering you a digital investigator who can actually investigate and triage on behalf of the SOC analyst, right? So now having these many number of models, we expect so many alerts or violations or outliers, right? But then what you see here as our SOC dashboard, 47,000 risky alerts, 40,000 noisy alerts, which have been auto-suppressed by machine. Again, here also we are not relying on human to do the investigation or triaging. This is something which machine has detected, and through AI we have been able to auto-suppress all these different models. Right now, let's take one simple example. This is one of the model, Okta geolocation based anomaly, right? This is where a user when logs in from multiple locations in short span of time, which is geographically not possible to travel, right? This is a simple SIM rule. What we are trying to do, we are computing every use case model rule. We are trying to compute the risk score, confidence, and efficacy level. Now, with this, we are telling the analyst how the model is doing, right? How the model is behaving over the past, right? Where is it really good, or is it the detections produced by this model are nothing but false positive? And that's where, if you see here, 149 suppressed entities, 315 risky entities. So that the decision making has been done by machine. What is risky, what is suppressed, right? And just to give you another glimpse of, like, again, here also we are not completely relying on machine. We have a human everywhere as part of the feedback loop and as part of the validation, where if something has been detected as suppressed or detected as noisy by machine, you can always challenge. An analyst can always challenge the decision by machine, right? Thereby, you can always mark something or revert something that was not noisy, that was actually risky, right? And there is another way analysts can provide direct feedback to the loop, where all the incidents being raised by machine, there is a way that analysts can actually mark it as a, again, when closing a ticket or incident, analysts can mark it as true positive, false positive, wrong detection. These are the 3 outcomes we support. Marking this will ultimately reflect on the mod. So this is a closed feedback loop where everything you do will be reflected on the risk score and confidence. Right. So I just want to, again, I know it's almost time. Any specific questions based on AMC, autonomous model creation, or our false positive detection engine?
Thanks a lot, Abhishek. I do have a few questions from audience, probably not related to the platform, but in general, right? I think we can answer them, and if there are any other questions, we can answer them offline as well. We'll probably take a couple of questions, so please drop in if you have any further questions. Yeah, there is one question before that. I'll take the older questions first. So are all the work in cybersecurity repetitive? I think probably Archan, it's for you.
No,
take that?
Not all the job are absolutely repetitive. Yeah, there are some things which are repetitive in terms of doing incident response. Like if you are responding to a phishing incident, it is repetitive, right? But scenario will obviously be different, and we have to triage a particular incident case to case basis. So not all the things are repetitive, but yeah, there are things which we do repetitive.
Got it. And there is another question which says, what would be the future of SIEM, right? So what your take on that? What is the future of traditional SIEM?
I think traditional SIEM is almost dead now. So all of the SIEM vendors are trying to do some innovation in terms of either merging the SOAR into their SIEM or creating another platform like XSOAR or similar kind of thing. So traditional SIEM is already dead. There are things where SIEM vendors also ingesting their ML stuff. Like if we talk about Elastic, they have ML modules in terms of their detection topologies and detection mechanism. But yeah, traditional SIEM is dead now.
Perfect. Hope that answers your question. I think someone, Arpit or someone, right? So Abhishek, I think we have a question for you as well. So what is the biggest, sorry, before that, there is a question on integration, how SIEM and other log sources get integrated with Cetas.
Yeah, so again, just to answer, we have 78 plus out of the box integrations, right? So I'll just give you a quick glimpse, right? So let me know if you can see my screen. So these are the different out of the box connectors we have, right? So these are, so
I don't see your screen yet.
I'm sorry, 1 second. Let me just quickly share my screen. Yeah, can you see my screen now?
Yes.
So integration has been flexible for us. Like I said, we have somewhere around 80 out of the box integrations or connectors. Any API or again syslog integration, or like you said, right, any SIEM, be it QRadar, ArcSight, RSA NetWitness, Sumo Logic, Splunk, right? So we do have flexible connectivity with all the standard SIEMs as well as endpoints or applications. Over to you, Adarsh.
Cool. Yeah, Sumit, hope that answers your questions, right? Yeah, I think we have a few more. Probably we can answer them over the email, but I think we are good for today. So yeah, winding up, thanks a lot, Archan, for joining today, right? For a beautiful session. So we will be looking forward to more sessions in the future as well. And thanks, Abhishek, again for joining and giving us the demo. So thanks, both of you, and thanks a lot, audience, for joining in today. And we will be, posting many more in the future, and hoping to meet all of you again. Thanks a lot.
Yep. Okay. Thank you, guys. Bye bye.
Good evening. Bye bye. Bye bye.